The agitation process is one of the most important within the chemical industry because the success of many industrial operations depends on effective agitation and mixing. However, due to the complexity of the transport phenomena involved, it is one of the most difficult processes to analyze and characterize. The geometric configuration is a significant factor in agitation systems. There are different tools such as air diffusers and baffles to improve the steering process. However, the design of the agitation or impeller mobile is the most important factor when defining the hydrodynamics of the agitated system. Agitators can be divided into two groups. The first consisting of designs that generate currents parallel to the impeller shaft, which are called axial flow impellers. The second group consists of agitators that generate currents in a tangential radial direction that are called radial flow thrusters. For these latter agitators, one of the most important design variables is the shear rate generated by the mobile. Currently, it is the Rushton turbine that allows to obtain a shear rate of 20 seconds squared minus 1. Finally, the objective of this project is to simulate in CFD a Rushton turbine and design agitation mobile which generates a higher power number compared to the Rushton turbine. To carry out this project, it was necessary to divide it into three parts: the simulation of the Rushton type mobile, simulation of a new mobile with specific parameters, and a comparison of both mobiles in order to determine the most optimal one. The simulation of the first model, Rushton, used the geometry of a stator of this same type provided in Autodesk Inventor. This geometry was imported to be able to perform the respective simulations in the Star CCM Plus software. For the selection of the meshing models, polyhedral cells were used in order to make a good discretization of the control volume obtained. Additionally, the prism layer model was chosen to obtain a good transition from the turbulent zones to the laminar zones near the walls. On the other hand, the surface remesher was used to obtain a mesh that meets a high cell quality and improve those axes or corners that generate discontinuous figures when the CAD is imported into the program Star CCM Plus. The mesh for the Rushton turbine resulted in 800,000 cells, and for the impeller resulted in 900,000 cells. However, both impellers have the same attributes